let's learn 2D numerical arrays in C. 2D array can be considered as an array of arrays. The elements will all be the same data type and will be organized in the form of rows and columns, and you can refer a 2D array to a matrix. It is similar to a matrix. The general syntax of declaration will be the data type followed by the array name. The first square brackets a number of rows, and the next square bracket the number of columns. And these elements, the rows and columns, can be accessed using two indices using nested loops. Now it's important that you understand the layout of the subscripts in order to perform operations on 2D arrays. For a 4x5 array, 4 rows and 5 columns, this is how the subscripts are going to be referred to. And when the number of rows and columns are the same, we refer to that as a square matrix. We'll look at a small demonstration on the declaration and usage of a 2D array to understand better. To declare a 2D array, like we saw before, we'll have the data type followed by the array name. The first dimension will refer to the number of rows, and the second dimension will refer to the number of columns. So this could be read as a 3x2 array or a 3x2 matrix. Now to give values to the matrix, initialize values, we can either do it statically when we write the code or read the values at runtime. Obviously we'll need a nested loop to read the elements for every row and column. So let's have subscripts I and j, and the outer loop always will be for the number of rows. So I will start with a 0, traverse till less than a 3, I++, within which inner loop is going to be traversing for the number of columns. So j equals a 0, j less than a 2, j++, and every time the values are to be read scanf, the format specifier, and then this is going to be read as ampersand of address of the array name I, j. So two indices to refer to each element of the array, and probably before this nested loop starts we can have a prompt, enter a 3x2 array elements. So some prompt given to the user to understand the dimension, and then after the values have been read, we'll again need a set of nested loops to display the 2D array in the form of a matrix. So we'll have a outer loop, and within a block we'll have the inner loop. So this is basically called the row major form, that is every row is going to be worked with, each element in the row is going to be worked with, whether you're printing or you're traversing to manipulate. So how will I show the data? I'll have a format specifier and then show the value of ARR of I of j. Now this is going to show, the inner loop is going to show elements in each row. When one row is over, for the cursor to come to the next line to start the next row, we shall have a new line happening there, which will cause the cursor to start printing elements in the subsequent row onwards. We have a prompt here asking for 3x2 array elements. Now we could have 6 elements entered in this kind of a fashion. So either using a space or a enter key, any white space, you can enter all the 6 values. And now this is shown in a matrix form, 3 rows, 2 columns. So this is how you get to read the values at runtime. Now instead of reading values at runtime, if you had wanted to initialize them statically, so at this point we could have assignment operator, and in curly brackets I'll enter the value for a set of values for each row. So the first row contains say a 10 and a 20, and then another pair of curly brackets. The second row has a 30 and a 40, and then the third row has a 50 and a 60. So every row I'm representing the elements in every row in a pair of curly brackets. So now when I run the code, the array has been displayed in matrix form. Now the curly bracket is also not needed. You could have just initialized the values in a linear fashion. So all the 6 values, if we had given separated by a comma in the form of a 1D array, it will still allocate the elements according to the dimension that you have provided. So the second dimension is really important. That will decide how many elements in every row, and thereafter the rest of the elements are going to be populated in the appropriate number of rows. So when I run the code, I'll still get the output in the matrix form. And another thing to be remembered here is, like I said, the second dimension is mandatory, but the first dimension is optional. I could have even skipped that and then given a set of values. How is this going to be understood by the compiler? Like I said, based on the second dimension. Now supposing I have changed the second dimension to a 3, the values are going to be taken 3 at a time. So the first 3 elements will be assigned in the first row, the next 3 elements will be assigned in the second row, and automatically this is going to be considered as a 2 cross 3. So even if the first dimension is omitted, it doesn't matter, but the second dimension is mandatory. But when you're omitting the first dimension, leaving it unsized, it's important that you statically initialize. When we have an unsized array like this, you can't possibly read the values at runtime. We must give the values at compile time itself. Now since I have changed the second dimension to a 3, I have to change my inner loop to a j less than a 3. But what should my outer loop traverse till? I should know the number of rows that are there in my array when I leave it unsized like this. So how to find the number of rows? Let's assume we have a variable rows, and that is going to be initialized with the result of, okay, first we'll see how many bytes the entire array is occupying. So we'll have a print here to show the size of the entire array, and then display the result of what is stored in the variable row. So when I run the code here, it's showing a 24. So the total memory occupied by the array is a 24. So based on this, to find the number of rows, it will be the size of the entire array divided by the size of each element in the array. So if I want to refer to the first element, I could say size of ARR of 0, 0. The 0, 0 will refer to the element in the first subscript, that into the second dimension that I have decided here, that will be a 3. So if I have to run the code here, so here the number of rows, I should have changed the prompt message here. So the number of rows will be 2. Now based on this, I can have my outer loop happening. So this kind of expression will let you know how many rows are there when you leave the first dimension unsized. So accordingly, if I run the loop here, the outer loop will run from 0 to less than row. So the number of rows are 2, and the first 3 elements, like I said, the second dimension plays a important role. The 3 elements are arranged in the first row, and the next 3 elements are arranged in the subsequent row. Now you could have given fewer elements too. Like for instance, I have given only these many elements. Now again, how this is going to be considered is, the first 3 elements will be populating the first row, and thereafter the rest of the elements will populate the second row. If I'm short of values, then the elements are array is automatically going to be filled with zeros. So these are different ways of initializing a 2D array and displaying the contents using a nested loop. Now let's consider a square matrix. I have a 3 cross 3 matrix. I have some values initialized, and by these sort of nested loop, I'm trying to show the subscripts, and this set of nested loop is going to show the elements. Let's run the code. So for all the 9 elements, the subscripts are like what's shown here. Like I said, it's important you understand subscripts to perform matrix operations. Now for instance, I want to work only with the diagonal elements. That will be 10, 50, 90, 30, 50 and 70. So if you look at the main diagonal is from left to right. You will find the I and j to be same, and the secondary diagonal, if one way of checking for the secondary diagonal elements, the summation of I and j, I plus j should be equal to the dimension minus 1. So my number of the square matrix, the number of rows and columns are going to be the same. So dimension, if it's a 3, the I plus j should be equal to the dimension minus 1. It should be a 2. So summation of I and j should be equal to 2. So if I had a check here before printing, it will print only exactly the diagonal elements. So the main diagonal elements check is going to be this. So either I and j should be the same, or I plus j should be equal to the number of rows or columns minus 1. And within this loop, I am trying to print only the diagonal elements. So the diagonal elements have been shown, and if you had wanted in that format itself as a diagonal format, then where it doesn't satisfy, we can try and have a set of spaces shown. So that will arrange the elements in a much more easier way to visualize. So only the diagonal elements have been shown. Another thing which is very commonly done is if I have to work with the border elements. So the border elements are that which occur on either all sides of the given square matrix. And if you notice, the condition is for the upper row of the border, my I is a 0, and in the bottom row I is a 2, and in the first column j is a 0 and the last column j is a 2. So any kind of a square matrix, a 3 cross 3, 5 cross 5, 7 cross 7, in order to locate just the border elements, your check can be if either I is a 0 or I is a dimension minus 1. So number of rows and columns are 3, so 3 minus 1 is a 2, or j is a 0 or j is equal to a 2. So in those places I will display the elements, in other places I will display the space. So I will get exactly the elements that are there in the border. If I had wanted the non-border elements not in the border, so just now it will be just for a 3 cross 3, excluding the border, it's only the center element. So what I could have done is just negated using a not operator. So not of this, where it is true, those elements are to be shown, which means the center element, that is in a 3 cross 3, the center element is a 50 when the borders are excluded, and that element alone is displayed. So making use of the subscripts, understanding subscripts, you can do a lot of operations on matrices. More codes on matrix operations have been listed here, and the solutions for all these codes are available in my GitHub repository, whose link is as shown below. Coming up next, we'll learn about the string data type in C and operations on them. Do subscribe for more codes on C.